Welcome everyone. My name is Zubair Altaf Qureshi and welcome back to this channel. And this is the second video of the ASA series that I am doing on my YouTube channel. And in my first video, we have gone through the basic overview of the ASA, uh, the history and the interface configurations. Now you know that ASA is a router, but it has some extra configurations on it. Okay, and we basically talked about the security level as well, and the name if that has to be specified on the interface. Now let's talk about uh, the traffic flow, default traffic flow of the Cisco ASA. So by default, as I said, and let me go back. Here, so we have the routed mode and the transfer mode. That's what I have already gone through. Now I want to talk about the default traffic flow of the Cisco ASA. So let me grab a pen. Okay, so as I said, by default you have the security level 100 and say so you have a firewall. This is my ASA firewall. Okay, and then you have two interfaces. Just keep simple. Okay, you have two interfaces. This is my inside interface and this is my say outside. Okay, and what I do is I assign a security level of 100 and 0. So 100 is my most trusted interface. Okay, and basically it's my inside and this is my internet. Okay, so so the first point is that the any traffic that is initiated from the high security level and it is going to the low security level is allowed by default. Allowed by default by the Cisco ASA. And this security level concept is just for the ASA. Okay, so let me just elaborate this point. Allowed by the means, again, what happens is all traffic which is unicast is allowed by default. Okay, from inside or say from high to low, any traffic which is unicast is allowed by default, but only TCP and UDP will be inspected. And what does that mean? That means that Cisco ASA, this ASA will create a connection table for the return entry. For the return entry, and that is done only when the traffic is TCP based or UDP based. So that means if from inside I generate a traffic or from an interface that is having a high security level, I generate a traffic that is TCP based or UDP based, the return traffic will be allowed by default. Because of what? Because of the connection table that I have here. This connection table is a reverse ACL, you can say, of the traffic that was initiated from inside. Okay, what do I mean by that? So for example, I have a traffic. Well, let me change the color because it's not visible, and let's erase this. So let's take this purple. So for example, I have a traffic that was generated from inside, and say the source of that traffic was say 10.1.1.1, and it was going to the destination of 192.1.100.1. Okay, that was my inside traffic. So the return traffic, return connection table will be the return of this traffic. So on the outside, something like this will be there, that any traffic that is coming from 10.1.100.1 and going to the 10.1.1 should be allowed. So this will be the entry. Okay, and this is just for TCP and UDP. So that is how it is. But what if the traffic is generated from outside? Let me clear this again. Let me take the eraser, and so I need to keep the ASA and all. So now this was from the high to low, right? But from low to high, Let's see what happens. So let me just delete all of this. I actually need the firewall. This one. Okay. So now the traffic that is coming from low to high. What happens to this? So by default, any traffic that is coming from low to high is dropped. There's an implicit deny for this. Okay, so how do you allow these traffic? You allow these traffic by specifying explicit ACL. So explicitly, you define an ACL saying this particular traffic from outside should be allowed to this interface or to this destination. So by default, what happens when the traffic is initiated from low to high? So first thing what is checked is the connection table. Okay, if no connection table is there, then the firewall looks for an ACL. If there is no ACL, it will go to the security level. Okay, and security level will deny it because it's low to high, right? So just imagine if a traffic is initiated from high to low, okay, so you have the initiator because this is from high to low, the AC will allow it, but when the traffic comes back, what does the AC look for at the first place? It will look for the connection table, and because it was, say it was TCP UDP, you have a connection table, and because of that connection table, this traffic will be allowed. Okay, so you need to understand this. But if the traffic is initiated from the outside, you don't have a you don't have a connection table, right? You don't have a con table. So what will happen is the traffic that is coming on outside will look for an ACL. If you don't have an ACL, it will be denied because of the security level. That's how the security level by default governs the traffic flow on the ASA. Okay, so let's wait a second. Let's go here, and I want to go to my slide here. So that is what I have mentioned in the slide. So the first thing is that this is the one, the highlight security level to high security level to low security level. By default, all traffic is allowed to flow from a high security level interface to a low security level interface as long as the routing information is in place. Obviously, after the check of the security level, it will look for the routing table, right? So that should be there in place, the routing. Okay, so then you have the although all traffic is allowed to flow from high security level to low security level, only TCP and UDP traffic is expected. So that's what I said, only TCP UDP traffic will have a connection table below, and we can change this. It's not like this is the default behavior that I'm talking about, but you can change this. You can inspect other traffic as well. Inspection creates a return entry in the connection table on the firewall. Wait a second. I'll clear this, and I need a dark pen. So I'll clear all the drawing. Okay. So inspection creates a return entry in the connection table. That's what I said, right? And because of that entry only, the traffic that is initiated from inside, if it's a TCP and UDP or any traffic that has been inspected, will be allowed to flow from the low to high. Right? Inspection creates a return entry in the connection table on the firewall. This allows the return traffic to come back. This is known as stateful inspection to low security level to high security. Okay, so again here you need to clear this thing. So you might encounter this term as stateless and stateful firewall. So this is nothing but this concept of creation of the con table. The firewall that creates the con table is stateful, which doesn't is stateless. Okay, so this was actually invented by checkpoint firewalls. This stateful inspection. By default, all traffic is blocked from low to high security level interfaces, right? So that is the default behavior of the Cisco ASA, that all the traffic that is initiated from low security interface will be blocked. If you want this traffic to work, you would need to create an explicit policy on the low interface to allow this traffic. This is done by creating an ACL, right? So this can be overridden by creating an ACL, which allows that particular traffic. When a packet hits a low security level interface, going towards a high security interface, it will check the connection table first. If there is no entry in the connection table, it will check the ACL for a permit. If there is no permit in the ACL, it will check the default behavior, and that is your security level. And because it's low to high, that is denied. Okay, so that's why I was saying that the the security level by default governs the flow of the traffic. Okay, so that is what I wanted to show you, and basically I wanted to show you how there are certain models of Cisco ASA, but this is the what do you say, a different one, 5505. How it's different is it has an inbuilt switch. Okay, so you cannot go and configure this interface with an IP address. No, you should create an SVI. Okay, you should have an SVI here, and you assign an IP address to that, and then you make that port part of that VLAN. Okay, so it likes as an works as an L3 switch with an SVI. Okay, so that's there's a slight difference on the. So you will have the interface configurations in the VLAN, right? And other models you will have directly on the interface. So I just wanted you to know about this this ASA. This is the smallest ASA, and this is just with this 5505. Okay, not with other ASAs. So okay, and then again, what about the security levels in same security level, right? So so for example, you have a Cisco ASA. This is my ASA, right? And you have one interface, you have two interface, and like this. So this is say inside, and this is say outside. I'll go a little bit slow because this is say DMZ and this is say DMZ2. Okay, so let's say this is security level 0, this is 100, and this is like 50 and 50. So what about the traffic? So low, this is high to low, allowed, low to high, denied. What about 50-50? What about the same security level, right? So that is what I was about to talk in the next slide. But so default behavior of this is blocked. Okay, so same security levels will be by default blocked, but you can override again this with a command that I'm going to show you in my next slide. So let me clear this again, and let's go to the next slide. Okay, and the next slide is saying that by default, any traffic going from an interface that has the same security level as the destination interface, it will be blocked, and it can be overridden by these two commands. You can see these two commands. So you have the intra interface and inter interface. So if the devices that are if the interfaces that are part of this having same security level and different name ifs, you will use these commands, this command inter interface. And if the security level is same and also the name is same, then you will have this intra interface command. Okay, so that is the whole concept of your security levels. Okay, then we have the access list. And why do we use an access list? So you, as of now, you should be knowing that access list is nothing but a rule, and it works like it works in an router. So you will have a top-down order here. So the access list that will be on the top will be processed first, and it will come down one by one. So where it hits the rule, it's done. So for example, you have a deny for that traffic here, and the permit of that traffic here, it will be denied, and next line will not be checked. And likewise, if you have a deny and a permit and then deny will not be working. So you need to be very careful with the order of the ACL that you configure. Okay, and traffic filter, each traffic flow session is processed only once. Top down, that's what I said, and until hit it will be processed. All parameters must match. Result is permit or deny. So you have an extended ACL here on the Cisco ASA firewalls. Okay, ACL types that I was talking about, you have standard ACL on source address, but you will not be configuring this, right? You should have an extended ACL and match on source or destination address, ports, protocols, and more, right? So you want that type of ACL on the Cisco ASA. Recommendations: specify entry on top, generic entries to the bottom, apply access list inbound. So that is the recommendations. Okay, just an example of the ACL here on the ASA. So access list, ACL inside is the name. This is the name, and then extended keyword. This is not mandatory on the ASA. Then you have the permit IP object my PC any. So this is actually what permit IP means, permit anything, and then you are specifying my IP my PC. So you have created an object which in turn will be binded to an IP address. So instead of typing the IP address again and again, you can just use this object in every rule. Okay, so this is what you have as an object in ASA. You can create host objects, you can create subnet objects, right? You can create service objects. So this is using nothing but an object. So like that, you have ACL inside, extended, permit IP. So this is permitting everything. Object is now inside net, and then the remote net, right? So this is my source, this is my destination. Likewise, you are permitting only TCP based traffic, and this is my source and the so this is like ACL inside, right? So this is the source, this is the destination. This is actually identifying a particular port or protocol on that, right? SMTP in this case. So likewise, you have all these examples. You can go through one by one. And next is to traffic on the firewall and through traffic on the firewall. So I'll be taking this what do you say topic in the next video where I will also demonstrate this in lab, because basically what happens is to traffic will always be like management traffic. You have telnet traffic coming to your firewall, you have ICMP traffic coming to a firewall. So those are the two traffic, and by default only service that is running on the firewall is the ICMP. So this is just an overview for this, but I'll demonstrate this in my lab. So two traffic will be basically destined to the firewall, to the interfaces of the firewall, whether it's the outbound, whether it's the inside interface, whether it's the DMZ interfaces. So by default you can ping on Cisco ASA, you can ping the interfaces because that service is running. So this to traffic is not controlled by your ACL. So you need to understand this. So if you want to telnet, you cannot have an ACL permitting telnet from any to firewall IP address. No, that will not work. You can have that ACL, but it will not work. Okay, and that is ACL governs the through traffic, not the to traffic. Okay, so we will see this in the upcoming videos. And enabling or disabling of a service on the firewall is per interface configuration. So this I'll be demonstrating. Not no other traffic is allowed to the firewall. Yeah. So that as I mentioned, that only ICMP services. That means you can ping any interface of the firewall from any direction. Right. So yeah. So that's it for this video, guys. And I'll be seeing you in the next video, and I'll demonstrate all what we have covered in these two videos in the next video, and we'll do a lab and I will demonstrate all these things to you in that lab. So stay tuned for my upcoming videos, and kindly do subscribe to my channel and like my videos and share as much as possible. And thanks for the 1K subscribers. Thank you. Bye bye.